What's up, everyone? Welcome back. Today we've got a beautiful geometry puzzle. It looks innocent at first, but the solution hides a clever circle theorem. Let's see if we can crack it together. Here's the setup. We have a rectangle, ABCD. Along the bottom side sits a semicircle whose diameter is AM. The arc of the semicircle just touches the top side of the rectangle at point P. It also meets the right side of the rectangle at point Q. Now, here's the key piece of information. Point Q divides the right side exactly into two equal parts. So BQ is equal to CQ. Our goal is to find the measure of angle BAQ. Let's call that angle X. The first step is to locate the center of the semicircle. Call the center O. Now draw the radius OP. Since the top side of the rectangle is tangent to the semicircle at P, the radius OP is perpendicular to that side. That means the height of the rectangle is exactly the radius of the semicircle. Let's call the radius R. So, BC equals R. But Q is the midpoint of BC. Therefore, BQ equals R divided by 2. Now join O to Q. Since Q lies on the semicircle, OQ is another radius. So OQ also has length R. Look at right triangle OBQ. Let's call the angle at O alpha. Using the definition of sine, sine of alpha equals the opposite side divided by the hypotenuse. The opposite side is BQ, which is R divided by 2. The hypotenuse is OQ, which is R. So sine of alpha equals the quantity R divided by 2 divided by R, which simplifies to 1/2. And when the sine of an angle is 1/2, the angle is 30 degrees. So alpha equals 30 degrees. Now comes the beautiful finishing step. We'll use the Inscribed Angle Theorem. The central angle MOQ measures 30 degrees, so the arc MQ also measures 30 degrees. An inscribed angle standing on that same arc is exactly half the measure of the central angle. The angle standing on arc MQ is angle BAQ. Therefore, angle BAQ equals half of 30 degrees, which is 15 degrees. And that's our final answer. If you enjoyed this problem, don't forget to like the video, subscribe for more geometry challenges, and I'll see you in the next one.